Hello, my name is Yon Kim. I'm from Michigan State University. Today, I want to talk about exciting results recently achieved, entitled Real-Time Observation of the Charge Diffusion Mechanism from Liquid to Solid State of Transition Metal Complexes. As you know well, copper-based molecular redox copper has shown effective Hall transport ability and device performance when dissolved in the liquid electrolyte as well as solid films. Due to the unique manufacturing process of those solid films, in which the organic solvent is simply evaporated to name the zombie cells, the mechanism of Hall transport with the solid state has been unclear, and it only has been speculated as Hall hopping. However, which inhibit further improvement and the development of design rules for highly efficient solid-state dye-sensor solar cells with molecular redox coppers. So, in this work, our group clearly proved the charge diffusion mechanism of copper complexes using in situ solidification electrochemical analysis with the modified Damsel application, and found transport mechanism changing of the copper complex from ionic to electronic Hall diffusion. And we also found that their separation rate constant was huge increase from the liquid to solid film up to 10 to the 8. For the method, we used the in situ diffusion tracking system using the microelectrode, and this system was developed to directly monitor the diffusion mechanism for the solidifying intermediate state and perfect solid film of the copper complexes. And also, we derived and introduced the modified Damsel application to fit and calculate the experimentally obtained data from the eChem analysis. Damsel application contained the physical and chemical exchange diffusion information, and here the exchange diffusion is dominated by the separation rate constant of the molecules. In our work, the data should be measured according to the concentration changing of the copper complexes, so we must consider the concentration terms in also physical diffusion. That is the viscosity terms. So we partially substitute the original Damsel application for the viscosity terms. And we successfully got the viscosity considered apparent diffusion coefficient as a function of the concentration of molecules, and also using the limit current density for the electrode. Finally, we made a viscosity considered limit current density as a function of the concentrations, and this equation has shown very well-fitting result for our experimental result. From the in situ electrochemical analysis using the microelectrode, we can get a linear current density, limit current density as a function of the concentration of copper complexes. Via the fitting using the modified Damsel application, we suggest that at the low concentration region of copper complexes up to around the 0.3, at limit current density, approximately linear increase with respect to the concentration, and we can recognize that this is a physical ionic diffusion region. But the concentration of the copper complex increased over the 0.3 moles. The limit current density began to increase the scale of the concentration of copper complexes. This means the high concentration region has totally different transport mechanism, which is electronic diffusion. The result can be explained in more detail in trajectory of the diffusion as a function of the concentration. At the low concentration region, the diffusion coefficient showed a rapid decrease, but over the 0.3 at high concentration region, we can see the linearly increased diffusion coefficient, which indicates clearly electrical diffusion region according to the Damsel application. From the experimental result and modified diffusion equation, we can also calculate the separator rate constant of the kappa complex solid, which is 10 to the 5th time larger than liquid one. We can expect that the slow separator rate constant occur the lower reorganization energy of the kappa complex solid, which would affect the fast dye regeneration and high quantum yield, as well as fast recombination of solid-state dye-sensor solar cells. Here's the conclusion. We have successfully observed the change of the diffusion mechanism for the kappa complexes during the solidification from the liquid to whole trace materials by the in situ solidification analysis. This result introduced the new methodology to analyze the transport mechanism of solid, leaving the mechanism of the charge transport in molecular-based whole trace materials. Please see this address if you want more information about this work. And this work supported by the Department of Energy in the United States. Thanks for